I'm Marissa.
And I'm Alana.
And we are doing the math and track and field. Alright, so the history of track and field. Track's one of the oldest sports, which is understandable because running, jumping, and throwing are all natural and universal forms of human physical expression. The sport originated from the first Olympic Games in 776 BC, when Coroebus, a local cook, was the first person to win a foot race, which was 600 feet long. And according to the Greeks, the honor of winning was better than the prize they received. And the first modern Olympic Games was held in 1896 in Athens, Greece. And this was a picture from the first Olympic Games in Greece.
Okay, so a little bit about the design of the track. One lap around the track is 400 meters long, and each track has a minimum of about 8 lanes. And each lane has a width of 1.25 meters, and lanes are staggered. Because the outside of the circle has a greater circumference than the inside of the lane, so they stagger them so that they all run the same distance.
Track and field dates back from the ancient times. The question asked throughout this time is, how can I be faster than everybody else?
So one of the areas that helps with you getting faster is running form. So your arms should be at about 90 degrees. Your head should be straight forward, and you should work for a cadence of about 90 strides per minute or higher. And it has been shown that more frequent strides that are shorter are faster than less steps and longer strides. Okay, so more on a perfect form. Shoulders should be relaxed, and so it allows for a fluid arm movement. You should lean slightly forward, so there's like a straight line from your legs to your head. Your hands should be kept like relaxed, and your arms should swing back and forth and not twisted, so it should stay parallel. And you should align your hips directly below your torso, and don't pull a miley and avoid sticking your butt out. Lift your knees at about a 90-degree angle, and feet should land right beneath your body.
Alright, so relays developed as a way for runners to carry messages across long distances. In ancient times, a message stick was delivered from person to person. They were introduced to the Olympics in the late 1800s, and they emerged in the U.S. in the modern Olympics when firemen did charity races, handing off a red flag every 300 yards. And we're going to be focusing on the 200-meter relay. There are 4 runners who each run a distance of 200 meters. The total distance of the race is 800 meters, which is 2 laps around the track. The runners must hand off a baton in the 20-meter exchange zone, or the team will be disqualified, and the person running must stay in their lanes at all times.
Okay, so now we're going to switch to how to measure speed and velocity. So speed is distance divided by time, and instantaneous speed is the speed of an object at an exact time, while average speed is, it takes like all the speeds into account. And
one announcement, this is for boys tennis. Boys tennis, your bus is leaving at this time from door number 1. Boys tennis, your bus is leaving at this time from door number 1. Thank you.
Okay, so now into velocity. Velocity is change in distance divided by change in time, and it is the rate of change of an object's position. And velocity is different from speed because it contains both speed and a direction. If it has negative or positive, then it is telling you a different direction that it's going.
Then the history of the math we're finding comes from well-known mathematicians and scientists. Aristotle put forward his ideas on why objects fell to Earth and also on motion in general. Newton's 3 laws of motion set the stage for velocity and gravity functions, and Galileo and Kepler made significant contributions for later developments in gravitational theory.
Okay, so now that we have talked about the history of track and the running form and velocity, we are going to now show you a video on the 4x200 meter men's relay from the 2014 Olympics in London. And once we're done watching, we will show you the math that it takes to figure out at which point a runner passes an opponent in order to win the race. And so while you're watching the video, there are two teams you should be watching. There's St. Kitts and Nevis, and there's the Jamaica's team. You can see that St. Kitts is really far ahead and Jamaica is back there. Now it's at this handoff that Jamaica starts picking up. And it's at that point that they start passing the St. Kitts. So these are the times. Jamaica got 1 minute and 18 seconds, and St. Kitts got 1 minute and 20 seconds.
Okay, well, so that you guys can see the board. So what we'll be doing is figuring out what time T will a runner get passed. So in this race, it's when Jamaica passes St. Kitts and Nevis. So how we figured out the last leg of the race's time, we took the final time. So for SKN, it's 1 minute, 20.51 seconds, minus when they got the baton, which is 57 seconds, and that equals 23.51 seconds. And then for Jamaica, their final time was 1:18.63 and minus 58.4. That equals 20.23 seconds. So this is how long the last runner ran their 200. And then, so to find the velocity, we took the distance, which is 200 meters, divided by the time. So SKN was 8.507 meters per second, and Jamaica was 9.886 meters per second. And then, so the velocity for St. Kitts and Nevis at time t equals 0 is 8.507. And it's at time t equals 0 because that's when the time starts. And then for Jamaica, it is at time t equals 1.4 because they started 1.4 seconds after St. Kitts and Nevis started. And then that is 9.886 meters per second. And then to give these runners credit for how fast they are running, we put it into miles per hour. And Jamaica was running 22.114 miles per hour, and St. Kitts and Nevis was running 18.03 miles per hour. So then we have to find the position, so we take the antiderivative. So it would be 8.507t. Normally be plus c, but if you plug in 0, c is 0. So just hit that, and then this would equal 9.886t plus c. And then to solve for c, we put it equal to 0 and plug in 1.4. And then we get 0 equals 13.8404 plus c. And so c equals negative 13.8404. So the position for Jamaica is 9.886t minus 13.8404. So then to find at what point they're the same distance on the track is we have to set the positions equal to each other. So it would be 8.507t equals 9.886t minus 13.8404. And then solve for t, so it's negative 1.379t equals negative 13.8404. And then t equals 10.0365 seconds. So when they've been running for 10.0365 seconds, that's when they're the same distance. And then anytime t is greater than this, Jamaica is ahead. And then to check our work, we just plugged in t into the position function. So for St. Kitts and Nevis, it'd be 8.507 times 10.0365, and that equals 85.38. And then for Jamaica, it's 9.886 times 10.0365 minus 13.8404, and that equals 85.38. And so at 85.38 meters is when they're at the same distance. And then so right here is just an overview of what we just did. There we go.
So other examples of like the math that we were doing is aircrafts taking off, falling objects when a ball is thrown off, the velocity of that, traveling cars and car crashes, and baseball speed of pitch.
And the winner is